Hey, this is Brock Lemairs, and in this video I'm going to go over the built-in math operators in the C programming language. And now when I say math operators, I'm talking about the ones that are automatically available in C without including any additional header files. There are certainly a lot of functions that have been developed to perform a lot of various math functions that are provided to you in header files, specifically math.h, but we're not covering that right now. What we're talking about is just the basics of what is included in C without any extra header files. Okay, so what C provides is a set of operators to perform basic math: addition, subtraction, multiplication, and division. And there's one little trick on the division when you think about the difference in data types. So we've looked at how we have integer data types, and we've looked at how we have floating point data types. So if you're going to perform integer division, you really don't want an answer that is a floating point number. Even though if you said, 4 divided by 3 is going to be 1 point something, 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 right? 1.3333. Well, your answer, if you're using integers as your inputs, you might want your outputs to be integers. So in order to handle that, what C does is it allows you to have an integer divide and also an integer remainder. So if you would use the / operator, which is division, on two integers, it's going to return an integer that is the quotient. And then you perform that same operation with the percent sign, and that's going to give you the integer remainder, okay? But then at the same time, if you use the / on two floating point numbers, the result will return as a floating point. So C automatically looks at the types of inputs that you have on the division and takes care of it for you. And we'll look at an example of that. Two other operators that are really neat are the ++ and -. These are increment by 1 and decrement by 1. And the way you use them is you just put them after the variable name, and it'll just take that variable and add 1 to it and store it back to it, okay? And same thing with -. Now these are called unary operations, and that's what you'll see in like the books and in the slides and everything, because they operate only on a single variable. Okay, so let's code along. What we're going to do is create a new folder on our Linux server called mod04_code along, and we're going to just get some experience with seeing how these operators work. So I'm logged into the CSCI 109 server over here, and what I'm going to do is take a look at where I'm at, what I'm doing, and here's all my other folders and files from before. So I'm going to go ahead and say make dir, make directory mod04_code along. And then I'll go ahead and say ls. So there it is. Now let's change into that directory by doing cd for change directory into mod04. At this point, I'm going to hit tab to autocomplete. It found it, completes it. And now I'm in my new folder. Okay, so let's start a new C program file called math_testing, which we'll do with vim. So I go vim space math_testing.c, and let me pull this over so it doesn't wrap, just so we have a little bit of room. And there we go. All right, so we're in Vim right now, and off we go. So I'm in normal mode by default. I'm gonna hit I to get into insert mode, and now let's create our standard block header. So I'm gonna do a block comment by / asterisk, and then say experimenting with math. All right, and then we'll include the standard IO header, which gives us the printf function, which is very handy. And then let's create the shell for our main program. All right, and then open curly, and we'll go all the way to the end and do our return 0 so we don't forget it. And then we'll close curly, and now we're set. Okay, so this is the shell of our program file. So I'm going to hit escape to get into normal mode, and then colon to get into command mode, W for write it, hit it. It's going to complain that I didn't put pound. So I save that. And now down in my second terminal, I'll say, where am I at? Okay, I'm going to change into mod04 and then do an ls, and there's my thing. There's my code. Okay. Now, these operators are really simple when you first start out, but what we care about mainly is the data types and how they're handled, because we kind of learned that these data types don't hold infinitely sized numbers. So let's go ahead and do this. Let's start off with just looking at addition. Really simple. So we'll go int apples equals, we'll say apples is a variable that holds 8. We'll say oranges might be spelled wrong, but it holds 5. And then we'll say fruit total is a variable that we won't initialize. And then let's do a line header or line comment and just do some adding. Okay. All right. So what I'm going to do is very simply, I'm going to go fruit underscore total equals apples plus oranges. Okay. Simple. Now let's print it out. So let's go, there are, and then we'll do, let's print how many apples there are, how many oranges are, and then the total. Okay. Or no, let's just do the total. There are, format specifier D, %D, which is decimal for an integer. And then I'll say pieces of fruit. And then I'll go return, done. And then I'll say the variable is fruit total. And let's go ahead and stretch that over so you can see it without a wrap. And so what we're going to do is we perform an addition. It's two integers. The output's an integer. And then we're going to print the integer in a printf statement by using a format specifier to hold where the number is going to come from. And then the variable comes after the closing double quote and a parentheses, or excuse me, a comma. All right. So in theory, this will just print 8 plus 5, which should be 13. Okay. So let's go ahead and do that. So I'm going to come down here. And I'm going to do this present working, or I'm going to ls to see where I'm at. Now let's go GCC and we'll do math testing. And I did that with an autocomplete. And now I'm going to go ahead and say, direct the output binary to .o math underscore testing. And we'll go. Let's do it again with warnings all on. Everything was cool. Still need a little bit more room. Now let's run it. So I'm going to go ls. There's my executable math testing. So let's go ahead and go math testing. And there are 13 pieces of fruit. Okay, very, very simple. Okay, just as you'd expect. All right, so now let's take a look at this. Now let's do this. Let's say now there are 2 billion pieces of fruit, 2 billion apples and 2 billion oranges. Okay, let's see what that means. So 2, 1, 2, 3, 1, 2, 3, 1, 2, 3. So that's 2 billion or 2 trillion. There I go, 2. 1, 2, 3, 1, 2, 3, 1, 2, 3. All right, life is good. So the answer should be 4 trillion, right? So let's go ahead and do, let's see, GCC and then run it. And there's negative 2 trillion 9 billion. What? What's going on? Why is this wrong? Oh, wait a minute. An int is a 32-bit signed number. It can only take on values from about negative 2 billion up, or 2 trillion up to positive 2 trillion. So the problem is that this does not hold, this cannot hold a number big enough to hold 4 trillion. And it's like, oh man, what am I going to do? Well, here's the first thing. First of all, you've come a long way if you can even understand what this means, because you have to understand data types. You have to understand what a bit is, and you have to understand integer encoding of signed numbers. So when you type int, you can't, as an engineer, when you're programming, you got to always think, how big is this thing? How much memory does it take? It takes 32 bits of memory. What does it mean if it's going to be an integer value that's signed? What's the range of those numbers? Okay, so let's look at how you could fix it. You could certainly just come in here and be like, you know what? I'm just going to long in it. I don't even care. I don't care about memory. I can use all the memory in the world. I'm a horrible programmer. I'll come down here and I'll do LD. You remember, LD doesn't stand for long double. It stands for long decimal. And so I just changed my data types to be bigger. Long int takes 64 bits. So let's see if that works. So I GCC it, I run it. Oh, it's so nice. Look at that. Now, what's the implication of what I just did? The problem is that I now use 64 bits for both inputs, 64 here, 64 there, and 64 there. Now, that's a lot of memory if you're using like a microcontroller, something that's small like a thermostat. And you know, sometimes you don't want to do that. So you got to think about like, how many apples do I really have? Like, is this something where I'm only going to have like 100 apples? Maybe I don't need a long int. But if you can understand what I'm talking about, you've come a long way. All right. Another thing you could do if you said, you know what, I want to use 32 bits. So I'm not going to use 64 bits. You could use an unsigned integer. Let's think about what that means. Unsigned. First of all, let's see if it works before we blather on about why it's so awesome. Okay, so here I have unsigned. Okay, now let's come down here, and the format specifier for unsigned is U. And that just, you just have to know that. You know, it's in the table from last time. So I GCC it. Let's go ahead and run it. Oh, it works again. Why did that work? It's because unsigned int is still 32 bits, but it's unsigned, meaning that it takes the 4 billion locations, 4+ billion locations, or 4 trillion, sorry, and it starts assigning the codes at 0 and it goes up. So instead of like using them all to go like -2 trillion up to +2 trillion, it goes from like 0 to 4 trillion. So that's why it works. So that's another way you could actually get around this and handle this number. But again, it's, you got to just know what your possible input ranges are. Okay, so now let's go ahead and see if this works on floats. Okay, so let's now say that I had 8.5 apples and somebody's cutting up our fruit here. And let's go ahead and say 5.25. All right, and then these guys are going to be floats. So let's come in here. So float, and then we'll come right here. We'll say float, and then we'll come right here. And we'll say float. Not even close. So float, float. All right. Now we got to update our format specifier to be float, but I'd like to make it only 2 decimal places. So I do %.2, which says the precision's 2, meaning there's only 2 places after the decimal, and then I say float. Okay, so let's come in here. Let's go ahead and GCC it. Let's go ahead and run this little buddy. And I got 13.75. So this works perfect on floats. Just piece of cake, right? Or a piece of fruit. All right, so here we go. Now I'm gonna come up here. Let's do some subtraction. So now it's just simple, right? So let's go, let's keep our ints going here. So let's go int, and then we'll go int, and then we'll go int, and then we'll do a subtraction. So we'll go int, and then I'm gonna go fruit if. And then what we'll do here, since this is decimal, we'll just see, or an integer, we won't have a fractional component. Okay, so now I'm gonna come down here and let me do this. I'm gonna say fruit total, apples, there's that many pieces of fruit. Now let's do this, fruit diff, and then say oranges minus apples, and then let's do printf, and then say oranges minus apples is, and then we'll put the format specifier for an integer, do a return, and then we'll say, substitute into that format specifier location, fruit diff, and test it. Okay, so I save that up. I come over here, I'm gonna go ahead and GCC it. It's saying, hey man, you got a problem here. You didn't update your format specifier for this little fella. So I left that as float. So let's go ahead and save that. No worries. Go ahead and fire it up, or excuse me, compile it. Fire it up. Let me make sure this is on the screen here. Okay, fire it up. All right, so it worked. We ended up with 5 minus 8. Everything's great, right? Now, that was cool because 5 minus 8 is -3. So not only did it work, but it did illustrate that you have to be able to assign negative numbers. So whenever you do subtraction, now you got to think about, well, wait a minute. About half the time, if you let the variables do whatever they do, about half the time you're going to have a negative number. And so you can't really use unsigned numbers unless you really specify the values, the range of what the inputs are. So whenever you use subtraction, you got to use signed. All right, now let's do multiplication. Now this is interesting because if I come in here, let's do int, and then let's do fruit product. And then let's come down here and let's do this. So I'm going to go fruit product equals apples times oranges. Nice. And then let's do a print f, and then we'll go apples times oranges is equal to, and then we'll say format specifier %d, and then we'll do a return, and then we'll say fruit product. Okay. All right, life is good. Save that up and see what we got down here. So I'll GCC this thing to compile it. I'll run it, and we got ourselves apples times oranges is 40. It's like, is that right? It's like, okay, let's check our thing. 8 times 5, lo and behold, it is. Life is good. Okay, now we won't do this in code, but, or no, here's something to remember. Multiplication, you really run out of room in your product quickly, okay? So in general, not in general, a fact is that if you have an n-bit number times an n-bit number, the result needs 2n spaces. So for example, if you did a 4-bit example or a 4-bit multiply, 4 bits times 4 bits needs 8 bits for the product. And you can see that if you did a 4-bit example of two unsigned numbers, the largest number you could hold in a 4-bit integer is 15. That would be 1111. So 15 times 15 is 225. If you look at what the answer would be, it requires 8 bits. Okay. This is what 225 looks like in binary. So if you think about 32 bits times 32 bits, you need to have an output that can hold up to 64 bits. Okay. So again, this is when you do math in a programming language, that's what you got to think about. It's not just throwing around math operators. It's about thinking about what is the result? What's the size of that result? Okay. So let's do the kind of one more here. Let's do division. So let's do fruit quotient. It's a long word. And then let's do fruit remainder. And this is now an integer. And let's go ahead and see how this modulo is what they call the remainder part actually works. Okay, so watch this. I'm going to say fruit quotient equals apples divided by oranges. Then that's going to give me the integer quotient without a remainder. But then if I do fruit, what in the world here? Fruit, so I got fruit quotient. Let me do this here. Let me call it rem just to make it a little bit smaller. So fruit remainder equals apples. And then when I do percent oranges, that thing right there is going to give me the remainder. And so we have values coming in at 8 and 5. And so the quotient will be, how many times does 5 go into 8? The answer is 1. How many remainders are there? It's 3. That's 2 different operations in C. So let's go ahead and print that out. So I'm going to go, I go boom, boom. I'm going to come right here and say print F. Apples divided by oranges. It's going to be quotient, format specifier D, with a remainder of, and then we'll say D. And now here what I'm going to do is put a return, and then I'll say my 2 variables. So fruit quotient, and then comma fruit remainder. Okay, and that line wrapped, which is super annoying. So let's do that. Try not to cover up the slides, but it's impossible. So let's go down here and go GCC. Then we'll run this little buddy. And lo and behold, there it is. 1 with a remainder of 3. Okay, so what if you do this with floating point? Well, it turns out floating point just works exactly how you would expect. It's just going to give you an answer that has the numbers in there. Okay, so if I came in here just to complete, if you came in here and said, okay, look, actually I'll come down here. Let me do it down here just so you can see it in one screen. So I'll go float apples floating point equals 88, and then float, and I say oranges underscore floating point equals 26, and then I'll say float, and I'll say fruit div floating point, and then I said, okay, I want to do fruit div floating point equals apples floating point divided by oranges floating point, done, and then I say print F, and the answer is apples divided by oranges equals, and I put format specifier for a float now, which is F, and then I'll just say return, and then I'll say put into there fruit div floating point. Now let's see how that works. First of all, you can't have that little fella, can you? So, okay, so now we come in here, GCC, run it, Oh, look at that. So it just gives you exactly what you'd think. It gives you the regular number. The only trick though with floating point is, remember, floats only have a precision of about 6 or 7 significant digits. So even this one right here, it's like once you get out to that 5 place, or that 5 digit, you're not looking so good. That might be inaccurate. And that's something you know because you understand floating point encoding. All right, let's wrap this up with some increments and decrements. This one is really simple, but it's incredible how often you'll use this. This is probably the one you'll use the most, and you'll see that once we get to like looping structures. Let's just say I had apps, and I said 8, and then I said int, and I said orangey, and I said 5, and I come in here and I said print f, and let's just do this. I'm just going to say %d return, and then I'll say print apps orange, and then close it. And then let's make sure that works before we go too far. So I go ahead and there it is, 8 and 5. And then all I do here is this. I go apps ++, and then I go orange, mine, and then I'm ready to go. I'm gonna come up here and I'm gonna copy this by doing escape YY, put P for put, and now I'll see what these answers are afterwards. So I go boom, boom. Oh, look at it. It incremented and decremented. Okay. So the last thing on this is that there is an order of precedence when you do these operators. So first of all, parentheses win. But if you don't have parentheses are always evaluated first. If you don't use parentheses, then what it does is C will automatically perform the unary increment and decrement before it performs multiply, divide, and remainder or modulo. And those will be performed before plus and minus. And then finally equals is executed. And why that's important is because when you look at your code, you want everything to the right of the equal sign to be evaluated first before it's assigned to the actual destination variable. So as an example, if you looked at these two, 7 times 2 plus 4, there's no parentheses. So it will do the multiply first. 7 times 2 is 14. Add 2 to it. The answer would be 16. In this situation, if I put parentheses, it would perform the 2 plus 2 first. So that'd be 4 multiplied by 7. That'd be 28. Okay, that is it. That is math operators in C, and see ya.